Hello, everyone. Today we're going to keep learning more about linear functions. Today we're going to learn about how to solve systems algebraically. So in the last lesson we learned how to solve them graphically. Today we're going to learn another method. I'm going to start with a warm-up. So when would graphing a system of equations be inefficient? What problems might exist when you try to solve a system of equations graphically? So I want you to think about this. I want you to write down your answers, pause the video if you need some time. Then I'll share some answers that I've heard in the past. Okay, so let's look at some answers that I've heard in the past. Okay, oh, what happens if my slope is like 50? Y equals 50x plus 200. That's really steep and it's hard to graph. Well, what happens if the answer is a decimal or a fraction? Like, I don't know where the answer is going to be. It might not be 3 comma 4 like it was in the last lesson. What happens if my answer is 200 comma negative 8 million? Because I'm dealing with real world money and other situations that aren't just in a 10 by 10 grid. Other answers that I've gotten that I find are pretty humorous. What happens if I don't have graph paper? Well, if you don't have graph paper, it's going to be pretty hard to graph and solve the system. So all these are valid reasons why we should have multiple different ways. Now, graphing will always work. If you have a large amount of graph paper and you know how to scale your axes and make a really, really big graph, you can do it that way. But sometimes solving algebraically is just a little bit more efficient, or we like doing it that way a little bit more, especially when we have 3, 4, 5 equations that we're going to work with. So we're still going to deal with systems of equations, so multiple equations working together. And today we're going to learn about the substitution method and the elimination method. So a system of equations. Okay, when I say solving algebraically, it means manipulating the equations, putting them together, eliminating variables, solving for x or solving for y, and then using that to find the other one. So your answer is still going to be an xy coordinate point. Now, substitution and elimination are two of the many ways to solve systems. In more advanced math, we learn about a process called solving with matrices, which uses the ideas that we're going to learn today with substitution and elimination. Now, and you've seen me make mistakes already in my videos. And then at the end I catch them because I check. Now you don't need to show your check, but I'd recommend putting your solution back into each equation, making sure that that solution works for all of the equations. Now the first method we're going to talk about is the substitution method. Okay, it's great when one variable is in terms of another, and we can do a replace. So it's super useful when one equation is in the form x equals or y equals. And we'll look at this example down here. So we have an equation in slope-intercept form, y equals negative x minus 1. And then we have an equation in standard form. Now, just looking at the bottom equation, we've learned how to get x by itself or y by itself. But I want a numerical value for x or for y. So what I see here is I see that I know what this y is. This y is negative x minus 1. So this y has to be negative x minus 1. Okay, negative x minus 1 is just a disguised version of y. So what I'm going to do here is wherever I see a y, I'm going to put a negative x minus 1. And I put it in parentheses so I remember what are the signs. I might have to multiply. And then I get an equation with one variable. And we're good at solving equations with one variable. But that's the goal, is can I eliminate a variable? And this time I did substitution. And now I'm going to start solving for x. So I'm going to distribute. The negative 3, negative x is 3x. Negative 3, negative 1 is 3. And then we're going to get combine like terms, move, isolate the variable, solve for x. Do all the steps that we've done for many years. We'll get x equals 3. Now we remember that my answer is a coordinate point. So it's an x and it's a y. So I'm going to go ahead and substitute the 3 back into the top equation. You can substitute into the bottom equation too. Doesn't matter, your choice. So I have negative 3, 3 was x, minus 1, and y is negative 4. So I write my solution as my coordinate point, and I test it into the top equation. Negative 3 minus 1 is negative 4. Looks good for that one. Now 4 times 3 minus 3 times negative 4. I can use my calculator for that. I can know that 4 times 3 is 12. Negative 3 times negative 4 is also 12, and I got 12 plus 12. And it works. I checked my answer. I didn't show the check, but I know for a fact it works. And this is substitution. Now, elimination method, we're going to combine the two equations in a little different method. Okay, I like to think of it as very helpful when both equations are in standard form, when the variables are lined up. We combine multiple equations into one equation. Now, we've learned in math that whatever you do to one side, you do to the other. And we're going to use that idea here, except 7 is equal to x plus y. So if I wanted to add x plus y to one side, I could add 7 to the other. Or I could add x plus y to both sides. Now what I see here is I got two variables. Now if I take and add these two equations down, I'm adding the same thing on both sides, just they look a little different. So x plus x is 2x. Y plus negative y is 0. Oh, so the y was eliminated. That's why we call it the elimination method. One of the variables eliminates, becomes 0. And then we got to add the right side as well. 7 plus negative 1 is 6. Now we got an equation. We still may have another few steps to go. Maybe in this case we have one step where we can solve for x. We still got to put the x in. I like putting it in the top equation. That's just the first one I always see. And I get y is equal to 4. Now this was the example we did graphing. And we remember the answer was 3, 4. So we're pretty comfortable with that. But if we're not, we could say 3 plus 4 is 7, 3 minus 4 is negative 1. My solution works in both equations. I know it's true. I know I'm correct instead of having to wait or guess or ask someone, well, what does the answer key say? I can be my own answer key. But Mr. Minowitz, what happens if it looks like this? This is a more complicated example where we got to do a few more steps, and that's okay. So I see this bottom one is nice standard form, and this top one is making me a little sad. Okay, it's kind of in standard form, semi-standard. The first thing I want to do is I always like to write it as the x term comes first, the y term comes second. That's how standard form is. And now my variables are lined up. So now I can add down and get 12x minus 6y. And there's a problem. I didn't eliminate any variables, so that's a problem. Can't do that. Maybe I could try subtracting. 3x minus 9x is negative 6x. 2y minus negative 8y is 10y. And once again, I did not eliminate any variables. So I'm starting to think that elimination might not work for here. But then I go back and remember that I said we can do whatever we want to one side of the equation if we do it to the other. So I want the 3x and the 9x to really be the same. So I want them both to be 9x. So if I take and multiply everything in the top equation by 3, I can get 9x plus 6x equals 144. And now I got something that I like. Now I got two equations that have the same x. So now I can work with this. I didn't change the bottom equation. Sometimes you have to change and multiply both equations and scale them up. In this case, I only had to do one. That's okay. So now I have to think. And some teachers like to teach it where they always get 9x and negative 9x. I like to give students the freedom, where if I see that they are the same term, I subtract down. So 9x minus 9x is 0. 6y minus negative 8y, and be careful if you got two negatives, so 6 minus negative 8 is 14y, and 144 minus negative 24 is 168. Now I'm solving for y first. I can do that. I can divide and get y equals 12. Now, I always like to substitute back into the original one to check or to find x. So I put 12 in for y. 2 times 12 plus 3x equals 48. And I could solve that. Okay, take some time, show your steps if you need to, be careful. And I get a solution of 8 comma 12. Now I could put 8, 12 in here. I could put 8 in for x and 12 in for y. And remember, this first one is backwards. So you'd have to put the 8 in for the x and the 12 in for y. And check, do both of the equations hold true? It's your choice whether or not you want to know that you are correct. And checking will help us to do that. So elimination, make sure that the variables line up. And sometimes we got to add, like the last example, and sometimes we got to subtract, like this example. Either or, we get down to one variable, we solve it, and we can do this. Now it's your turn. Pause the video. You can use elimination, you can use substitution, you could try these three problems and try different methods. Figure out and learn how to do both of them so that you're not always stuck with, oh, I only know how to do this method, and this method is going to take a long time. Remember when I said that I would use each method and try it out. Unpause the video when you are ready for some solutions. Okay, so we are ready to see some solutions. And there they are. So this first one, I'd recommend using substitution because one of them is y equals. And I got a solution of 6 comma 11. And if you didn't get that, go back and check. Maybe you messed up a negative sign. Maybe your multiplication was wrong. We get better by practicing and seeing what our mistakes are. Now the second one, I see they're lined up, so I would do an elimination. I multiplied the bottom equation by 5, but some people like to multiply the bottom equation by 2 or negative 2. Okay, if you like to get positive 4y and add down, you can multiply the bottom equation by negative 2. It's all up to you. There's many different ways to do it. You need to figure out which one you're comfortable with. And once again, you get a solution, 5 comma 4. Now the third one, I don't care whether you use substitution or elimination, I'd probably use substitution. But eventually you get something like 6 equals 8, or if you did it a different way, maybe get 0 equals 2, where there's no x's, there's no y's, the left side doesn't equal the right side, and you get no solution. Now if I graph these are going to be parallel lines and they're not going to intersect. That's okay. When you get to this case, you get no solution. Now here's 3 more if you'd like to try. Once again, pause the video. In a few seconds, I'll unpause it. I'll show you the answers. Okay, here we go. Let's take a look. So once again, I get a case where these are parallel lines. I eliminate down, I get left side don't equal the right side, no solution. Then this middle case, I do a substitution, combine like terms, simplify, 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 and get to 10 equals 10, or 0 equals 0. And I get infinite solutions. If I graphed these two on the same graph, they'd be the same exact line, which is awesome. And then this last case, once again, I could get one solution, that they intersect at one point. So the more you practice your algebra, the more you practice combining like terms and elimination and substitution, is how good you get at doing these and how you get to minimize your mistakes. I've made them all, and I'm expecting you to make mistakes as we go through this and learn, do I have to be careful? Where am I making my mistakes? Is it the same place every time? Or I make no mistakes and I get them all right, and that's awesome. So solving algebraically means manipulating the equations. Sometimes we use substitution, sometimes we use elimination. And just like graphing, we could have an answer be an xy coordinate. Maybe there's no solution, or there's infinite solutions. And any of them are as likely as the other, especially if I make up random equations. So don't say, well, Mr. Millitz is always going to make an xy coordinate. Sometimes it will. And that's why I recommend checking your answer at the end of the problem so that you know that you are correct. And this is solving systems algebraically.